So hello and welcome to another conversation on corporeal architecture. Today I'm very happy to welcome Tiziana Proietti and Sergei Gepshtein. I will now make a short introduction on the work of both of them, and then we can start with the presentation. Tiziana Proietti, PhD, is an architect and educator. She earned her doctorate from the Department of Architecture of the Sapienza University in Rome in collaboration with the University of Technology TU Delft. Her doctoral dissertation concentrated on the theory of proportion in architecture. She is an assistant professor at the University of Oklahoma, where she directs the Sense-Based Laboratory. Together with the scientist Dr. Sergei Gepshtein of the Salk Institute for Biological Studies in California, she is developing an interdisciplinary program of research which will bridge neuroscience and architectural design and test age-old hypotheses about the human response to architectural proportion. Sergei Gepshtein, PhD, is a scientist working in the areas of perceptual psychology, systems neuroscience, and computational neuroscience. He is a member of the Center for Neurobiology of Vision at the Salk Institute for Biological Studies in La Jolla, California, where he studies perception and active behavior from the mechanistic point of view of neuroscience and from a point of view that respects visual experience as a research focus in its own right. He also directs the Center for Spatial Perception and Concrete Experience at the University of Southern California, Los Angeles. He is the inaugural recipient of the Harold Hay Research Award from ANFA in 2013. Thank you very much, Tiziana and Sergei, again for being here. So I will share the screen now. And
can I share my screen now?
Yes, yes. So you can start.
Thank you so much. You can see, right?
Yes.
Perfect. Let me move this thing. Okay. Well, good morning, everybody. I'm very happy to join the corporeal architectural conversation, and thanks, Maria, for having us to join this conversation. Today, I'm going to talk about perception of architectural proportion studied with the methods of sensory psychophysics. This research is conducted at the Sense-Based lab based at the University of Oklahoma, where we conduct psychophysical experiments to test the perceptibility of architectural proportion and eventually the effects that proportion has on human behavior. The research team is composed by myself, Dr. Gepshtein, and 5 research assistants, Joseph, Jonathan, Litz, Eli, and Winnie. The research assistants come from the departments of architecture and psychology, creating the right team to conduct interdisciplinary research between architecture and neuroscience. Well, for centuries, architects have changed proportion with symbolic and aesthetic values. Proportion has been considered representative of canons of ideal perfection, often related to the proportions of the human body. And its use and study has mainly referred to two-dimensional drawings imposed upon buildings, facades, and plans. However, to understand the effects that proportion has on the experience of the built environment, I think it is necessary to take into consideration the three-dimensionality of objects, the moving observer, the distortions resulting from perspective, and the human ability to discriminate sizes. To start, we ask under which conditions architectural proportions are perceptible by human beings who move freely through the built environment and observe it under various distances and angles. And eventually, we ask how such perception may affect the human behavior. We start from forerunners of the empirical approach to architectural proportion. One interesting figure that gives inspiration to the research is the Benedict monk and Dutch architect Hans van der Laan. I started studying the work of van der Laan about a decade ago for my PhD dissertation. And today, together with Dr. Gepshtein and my research team, we conduct formal studies on the perception of proportion inspired by the theory of van der Laan. Van der Laan invented, or better as he was used to point out, he discovered the plastic number proportional system, a system that starts from an investigation about the human ability to discriminate differences in size. Van der Laan theory starts from a very basic observation. He noted that when we measure any object, we repeat a module as many times as needed to cover the dimension we want to measure. To do so, we use units of measure such as the meter or the feet. And Van der Laan calls this quantity the discrete quantity. But he also noted that in nature, such quantity does not exist. In nature, sizes stretch to the infinite and cannot be constrained into a number of units. And such quantity he defined the continuous quantity. From this basic observation, he attempted to bridge the gap between these two quantities, the discrete and the continuous, and tried to understand the way humans perceive sizes. He starts asking, what is the just perceptible difference that we can detect when we compare objects of similar size? To demonstrate and study the just perceptible difference among sizes, he conducted informal studies. In these informal studies, he asked to a number of subjects to sort objects by similarity of size. In this drawing, you can see the first experiment he performed. You see 36 squares, and these 36 squares are the subject of the experiment. Subjects are asked to sort groups by similarity. The gray squares that you see here are the one sorted and considered similar. And moving on, in the drawings, you see that the grouping takes place and more groups are selected till the very final stage where you have the groups. And a number of groups that Van der Laan calls types of size. Sizes belonging to the same group, which are, for example, this one, differ of a small margin of size that Van der Laan calls the margin of size. The gray squares, these squares that you see here, represent instead those sizes which difference one to another is relevant and distinguishable to the eye. So according to Van der Laan, the squares into each group are not enough different for the eye to be appreciated. According to him, this difference is not enough. And then the difference from the gray squares is just distinguishable, so it's relevant to the eye. These measures, the gray ones, he calls the transition measures or the authentic measures. And they are the measures of the plastic number proportional system. With the plastic number system, Van der Laan wanted to build intelligible buildings, or better, buildings that could resonate with human perceptive aptitudes. And here you can see the plastic number measures and the relationship between the different aspect ratio of the system. Van der Laan created proportional tools to teach his system and conduct his informal studies, as well as design his buildings. Among the different tools, the Morphotech, this pyramid of objects, is the most relevant. The Morphotech is composed by 120 pieces and is the object that we use in our experiments at the lab. The pieces are organized in a pyramid of 8 layers. The authentic measures of the plastic system are used on each side, and they are repeated on the height, length, and width of the pyramid to create the 120 pieces, divided in 4 different groups. The blocks, this one, which are 60, and then the slabs, 20 slabs here, 20 bars, and the white forms, which are basically the forms intermediate between the other groups. And this is the base of the pyramid with the different proportions: 1 to 1, 3 to 4, 4 to 7, 3 to 7, 1 to 3, 1 to 4, 1 to 5, 1 to 7, repeated in the diagonal at different scales. Now, for our experiments, we start from the Van der Laan study, and we try to conduct formal investigations, formal studies. And we started with two different approaches to study the perceptibility of architectural proportions. In the first set of experiments or approach, we have the observer stationary looking into a custom designed perspective machine. In the second approach, the observer is mobile and is inside the machine or the box, if you want to call it. Let's look into the first approach. For the first approach, we have designed and built an observation device that exactly we call the perspective machine. The machine is a version of the camera obscura and stands on a central structure. On one short side, there is a stool for the subject, the observer, to sit. And there is a sliding panel that affords both monocular and binocular vision with a pinhole. There is a chin rest and head rest. Inside the machine, there is a shelf, and the shelf is engraved with a grid, 7x7 grid. Each location of the grid is marked with 11 different orientations, and the pairs of objects are located on the shelf. On the other side of the shelf, there is also a door for the experimenter to open the machine and put the stimuli, the objects, into the machine. Pairs of blocks at different orientations and location are placed inside the machine. In this experiment, we use 4 blocks of the Morphotech, the 1-to-1, 3-to-4, 4-to-7, and 3-to-7, these 4 elements of the Morphotech. And objects are painted in gray to minimize the texture. And diffused light is used to avoid shadows inside the machine. The observer is asked to judge whether the larger object is the one on the right or the one on the left, on a scaling rate that goes from 1 to 6. 3 and 4 indicate that the subject is unsure about the answer, and 1 and 6 indicate that the observer is very sure about the answer. Here you have an example of the stimuli. Although they appear very similar, the block on the left, which is this one is 1-to-1 in the ratio 1-to-1, and this other is 3-to-4. But they are at different angle, 75 and 150. And this is one of the possible conditions. In these photographs, you see the realized machine working. So here you see the slide panel with the pinhole. When it's closed, of course, you have monocular vision. When you open it, is binocular vision. Here the stool for the observer to look into the machine. And here you have the door that is used by the experimenter to place the objects into the machine. And this is the experimenter placing the object into the machine. And you see on the shelf, there is the grid with the different orientations to place the objects in the right location and the right angle. And here I want to show a video where you can see what happens inside the machine. Please tell me if you can see when I run it. Can you see it?
Yes, yes, it works.
Okay. And here you can see all different conditions. And in the final image, you see the two objects were very different, but in some conditions they appear to be similar. At this moment, we are still at the stage of experimental data analysis. We are collecting the data from different subjects. And we are now just at the stage of having some hypotheses for the experiment. We noted at this stage that some conditions allow higher percentage of correctness in the answer. So they appear to be easier at least. And this happens when, for example, at least one object has an orientation perpendicular or close to perpendicular to the subject line of sight, like in this case. Or, for example, when a relative angle between object is closer to 0 or near to parallel, like in this case. And we also noted that actually conditions become more difficult when, for example, objects are slightly angled from the subject's line of sight, like in this case, or when the relative angle between the object is larger. For example, when object is 60 and another to -60, this creates a bit more of difficulty in the judgment. We also started exploring different points of view with an online experiment, a digital version of the experiment that is available online, where we basically try to explore 2 points perspective and 3 points perspective. Since in the machine with the pinhole, we can at this stage only afford the 1 point perspective inside the machine. So we started exploring different points of view for the experiment. The second experiment we are building, the second approach, is still at the initial stage. And we have designed also, we are designing now a new observation device for this experiment. This time, the perspective machine is a structure that affords movement of objects inside a black painted room. The objects are positioned on a structure and can be moved at different height and rotated at different angles. A grid on the floor is used to place the objects and control the movement of the observer. And diffused light is used to help the observer to focus on the objects. We simulate in this room 3 different architectonic conditions. And here you can see a fourth condition where we have two three-dimensional objects and the subjects look into the objects. For this experiment, we are using the bars of the Morphotech, so the 127, 125, 124, 123. And in the previous experiment, we used the slabs, these other objects. Another possible conditions we are simulating is when you have 1 three-dimensional object and 1 two-dimensional, for example, a pillar and a window.
Oh, got it.
And then one last conditions we are simulating is when you have two-dimensional objects that simulate, for example, windows in a space. These are some of the images of the building of the machine that is now at the stage, at the 4th stage. We are really building that in these days. And we are this time using the software processing to simulate conditions and explore possibilities to run into the machine. And I can run this video so you can see. Can you see the video?
Yes.
Okay. So basically we are now with processing, having these volumes running into the box and see what happens when we start rotating, moving them up and down. And in this way, we try to explore possible conditions that we could run into the room. And of course, these 2 experiments allow us to approach the perception, the study on perception of proportion at this stage with the objects simulating the architectonic space, but eventually what we really want to do is to get into the building and test those hypotheses both in the virtual and physical reality. Thank you so much.
Thank you, Tiziana.
Tiziana, stop sharing.
Yes.
Okay.
Thank you for this really interesting presentation. For me, it was the first time that I ever heard about these experiments. And my first question to you is that when you have this setup for the experiments and you have the user observing where the objects are, which are the measures that you use to quantify and qualify the user experience?
So I'm not sure if I understood your question, but basically the subject is looking into the machine in the case of the first experiment, and is given a key numeric keypad where there are 6 numbers, from 1 to 6, and the subject is asked to basically push the number. 1 and 6 indicate that he's very convinced that, for example, 1, the object on the right is larger, and when is 6, the one on the left is larger. And then when he's undecided, very undecided, you can push 3 and 4, or when is in the middle, you have 2 and 4, yeah. So basically the idea is to work on a rating scale to understand the accuracy of the judgment in the observer. And once we have that, we collect all the data in our MATLAB code, and we put together all the information, and we build the psychometric functions, which is the stage where we are now, to understand the level of percentage of correctness of the answers. And the main idea of the experiment is really to understand the threshold of perceptibility. So when, how is the threshold of perceptibility of proportion in the subject, when you can or cannot discriminate.
Could you give us a little bit more information about this psychometric? Because for our students, it's the first time that they hear about this. So a very simple definition.
Yeah, I think Sergei could help on that.
Yeah, I'll be happy. I'll be happy too. And Tiziana, thank you so much for preparing this beautiful presentation. I think Maria just asked a crucial question about the units of experience. This is the fundamental question every time you're trying to understand how metric units of physical objects in the outer world, so to speak, relate to experience. What are the units of experience? You don't measure experience in meters or kilograms, right? These units are not suitable for mental measurement. So the discipline that we are using, the scientific discipline we are using in this research is called psychophysics. It was invented in the middle of 19th century by a German polymath, Gustav Fechner, who was a professor of physics at the University of Leipzig. He was one of the first to ask this question. And he invented the scientific discipline, which is called, by himself, psychophysics. And the goal of that discipline was to establish this mapping, this correspondence between the world of physical objects measured in well-known metric units, meters, kilograms, pounds, brightness units, candelas, etc., on the one hand, and mental processes. So the invention that he made, and that was really the key idea that created the discipline of psychophysics, was the notion that Tiziana just measured. It's called just noticeable difference. So just noticeable difference, according to Fechner himself, was a unit of mental measurement. So you could consider multiple physical objects and create a scale out of them, where certain physical distances or differences in sizes or weights or whatnot are translated into just noticeable differences in mental sense. So just noticeable difference is the amount of physical distance that produces in the subject a sensation of difference. And what is remarkable in that storyline that Tiziana just presented, that this architect, Hans van der Laan, much later than Fechner, and to our knowledge, he was not aware of Fechner or any of the contemporary science, and he was working in the early 20th century. He effectively came to similar methodological assumptions. So what he was doing, and in the experiments that Tiziana just described, he was trying to find just noticeable differences in proportion. And this is the crucial step. And I think for this group called corporeal architecture is crucial, because here we are trying to understand proportion, not in terms of divine authority, not in terms of mystical powers, but in terms of how human beings of flesh and blood are capable of discriminating those proportions. So van der Laan's work and the work that we are doing with Tiziana now are essentially first steps in the history of proportion of thousands of years to ground understanding of how we perceive proportion in human capacities, human faculties of perception and judgment.
Exactly, yeah. I think this is fantastic that you brought more information about the psychophysics and the connection to van der Laan work, which is remarkable, because van der Laan, I think the main thing that needs to be said is van der Laan was really able to look at proportion from another perspective. And this is very difficult from the architectonic point of view, because proportion is something very rooted in the history of architecture and theory of architecture. And majority of the time, still today, when you talk with architects, there is a lot of connection to beauty and some symbolic meaning. And the idea of Van der Laan was really to understand how proportion resonates with human beings in a very sensorial manner, you can say. So this is very valuable to re-understand what, as architects, we can do with proportion, and at which stage proportion can help us in the design of our buildings.
Exactly. Thank you, Tiziana, and also Sergei for this explanation, which really grounds the whole presentation. Because also when reading the paper that you shared with us and that we read to prepare for this conversation, what I found really interesting, and I hadn't heard about Van der Laan's work before, what I found really interesting was that he got this idea of working with this topic from very practical corporeal experiences. He was at the construction site with his father, and it was through this really corporeal experience that he figured out, got triggered his curiosity, as Tiziana wrote in the paper, got triggered to figure out how can we make systems of categorization to make these distinguishes between sizes. And also an interesting thing was that you mentioned in the paper, that these things don't, the measure doesn't exist in nature. It's something that we as humans do with the tools to adjust to something that we can verify in nature.
Yeah, I think it's very interesting because I was lucky to stay a lot of time in the Netherlands, and basically I was trained by students of Van der Laan, included one of his students, Leo Dammers, for many years. And he was always describing all this idea very simply. So the idea of discrete quantity and continuous quantity of Van der Laan is pretty simple. So what he says is that when we measure things is really an illusion, because when you, for example, have an object and you apply your meter and try to repeat the module, you think that you are measuring, but you're just counting, because you count the units that can meet the final dimension you want to measure. But there will always be some kind of left over that goes to the infinite that you cannot control with your unit of measure. And this is the contrast that happens between the continuous quantity and the discrete quantity. And for example, when he says, like you are in a forest and you have a number of trees around you, you can count those trees. But if I ask you how tall is every single tree, it's very difficult for you to give a precise dimension, because that dimension is not under your control. So it was really trying to bridge the gap between the two different dimensions, and the system, the plus in number system, is really the result of that. And he solves the issue with the idea of type of size and margin of size, which is what Sergei was explaining as the just perceptible difference. He tries to understand at which stage how, like human beings can really discriminate size. In terms of what we can really afford in terms of our limited perceptive aptitudes. And this is very important also for architecture and when we design, because we should be able to understand the abilities that we truly have in terms of discrimination. I don't know, Sergei, if you want to add something on that, but it's...
You're beautiful.
I have a question. So, now that you're working in these experiments, can you already make some conclusions that relate this to decision making?
We tried many times, we discussed with Sergei many times about, because the final stage of the research, the final goal of the research is really to understand how proportion may affect human behavior. And I questioned myself many times also before I started the research with Sergei about how we experience buildings and how proportion may affect our behavior in the space. And I always had in mind this example that worked for me. For example, imagine that you are in a church, in a nave, in the central nave of the church, and you have the pillars on both sides. And what happens is that the distance between those pillars inform your piece of the work. Like if the pillars are very close one to another, you perceive that the space is longer, and you start working faster, most probably, to reach the altar. So it must be, of course, this is not tested, and we need to test it once, at one point during our experiments. But I believe that proportion really contributes to the way we move in the space. And actually, Van der Laan was describing this as, actually, he was a Benedict monk, and he said that the effects are really describable as the liturgy. And for Van der Laan, liturgy was the set of gestures and actions that we take into the space. And it's almost like a choreography that comes from the building. The building is asking you to move in a certain way. The building is asking you to, like slow down or be quiet, is really asking you. And the idea of proportion for him was really connected to this liturgy as a performance that happens in the space. And I think this is the ideal stage that we could reach if at one point with all these formal studies, we can really understand how architects can use proportion at the advantage of the experience of the human being in the space.
And if I may, I will just add a couple of examples of how those practical implications could look from this sort of research. I'll just give you two examples. One is how the designer would use proportion in their work. And by designer, I mean generally design of objects, furniture, buildings, cityscapes, etc. So in this example, let me consider how a practicing designer would use one or another system of proportion. Even though proportional systems exited, so to speak, the center stage of architectural design, still practicing designers use proportional systems. Even book illustrators, every kind of designer that I encountered, they use some sort of proportional intuition here or there. So what our research could help to understand is where the designer could expect that their proportional thinking would have an effect on the user. So that the designer could have in his or her mind certain notions of which proportions are good or bad. What we could help that designer is to appreciate which of the proportions that they use could be actually effective for perception. It's just as simple as that. So the designer could have a notion that, for example, at this scale of the drawing or the scale of architecture, the difference between proportions of 3/4 and 3/5 would have an impact on the person experiencing architecture or the drawing. From our work, we could predict under what conditions these differences in proportion would really have an effect. And what we are learning that under most conditions of viewing three-dimensional objects, many of these proportions are simply indiscriminable. Mm-hmm. So that the designer would have a realistic expectation of what their design would have on the person. And my second example is linked to the first one, because given those angles under which people experience proportion, perceive it or not perceive it, under these angles, we could predict the structure of experience of the built environment, for example. So for example, if you know that under a certain angle of say 60 degrees, these two proportions are indiscriminable, when you have these proportions built into the environment, you could actually delineate in three-dimensional space the areas in which the proportions will have the effect and where they will not have an effect. So that you could build a map of experience in terms of where these proportions will have an effect on the person in a three-dimensional environment. And I would call that approach sensory mapping. So you could build a map of potential experiences, and in the fullness of time, I imagine this sort of considerations could be built into your design software, in your CAD system, so that you could, as a designer, you could actually predict different zones of experience in the built environment.
So, can I ask a question, Maria?
Yes, go ahead.
Thank you so much. Hi, Sergei. And Tiziana, very nice to see you. I love this presentation, and it just reminded me, it was interesting. I just had a lecture in my class by a woman who's from Cooper Union, who specializes in Khan, his FDR Four Freedoms Park in Roosevelt Island. And she presented the drawings, which were drawn to 1/32 of an inch. And she wondered how, why they did that. Why did they draw the details to 1/32 of an inch, which was not perceptible either by the public or by, or would even be constructible. It was very interesting. So I just wondered, in this experiment, do you differentiate between expert versus novice, or do you see this as a biological, like innate sensitivity, or do you think that sensitivity to proportion is something that is cognitive or learned over time? Like if somebody pointed out, like for example, my husband might be able to differentiate between two notes that I wouldn't be able to because of his learning of music. So I just wondered, is there a way, would that figure into your map, I suppose?
Yeah. Well, I just can say that for our experiments now, we are not having subjects educated in architecture. So we are always trying to have subjects that are coming, in general, they are students coming from other departments, no architecture. And if they are from architecture, we just accept freshmen who just were introduced to the architecture because, as you said, it may be that there is some different understanding already, advanced understanding of proportion in terms of training the eye to detect or recognize those proportions. But I mean, at the end of the day, I really think that the investigation is really trying to understand the universality of perception of proportion and understand how, in general, human beings do perceive and discriminate proportions. So I would say that the research is really aiming at that. But for our experiments, we are trying to be as much as possible trustable in terms of data, and therefore we are not using architects as subjects. Don't you agree, Sergei? I don't know what you think.
Yeah, absolutely. Our approach is universal. Of course, architects build, in some cases, they build certain things for other architects. So it's a self-contained, decadent circle of architects building for architects, and they give each other prizes and criticize each other's work. But in the end, in my sort of scientific outsidedness, I want architects to build for us, normal human beings, untrained in architecture, which is why our starting point is really students and ordinary people who are not trained in discriminating proportions. Having said that, I want to mention that for training architects, there have been attempts in the 20th century to use an approach of the sort that Tiziana was talking about in order to help architects develop certain proportional sensibility.
Yeah.
So one example, and we were writing an article about this with Tiziana now, there was this school in Moscow, in Russia, at the same time where Bauhaus was trying to be scientific. These fellows in Moscow were in a school called FUTEMAS, which means All Union Art School. I mean, after that revolution of 1917, they did many experiments, as you know, in avant-garde art and architecture. So there was this school called FUTEMAS in Moscow, and in one of its departments, they were inspired by psychophysical science of the time, and they built these machines in which they wanted to train. First of all, they were admitting students into the school based on their aptitude in discriminating proportions, and then they were trying to train students to improve their ability to discriminate proportions, slants, size differences at different distances from the observer, and similar. So there is room for using this approach in training the next generation of architects, I believe.
Yeah, and I would say that our approach is really in between the Theo van der Laan, who was basically conducting informal studies about proportion, and then also this example that Sergei is bringing by Ladowski in Moscow, where they were building devices, observation devices, to conduct the experiments. So we are in a way doing both of things. We are building our own machines, let's say, and conducting the experiment to the machines. And at the very end, the idea is really to bring this system in the studio and imagine a new format of the architectural design studio, where we conduct experiments with the students and at the same time design, thanks to the hypotheses or data collected in those experiments.
Yes, and I think this is a very interesting point that you brought up, because architects also have a tendency of forgetting that they are normal people too, and they are users too, first of all, and they have a body, and not just a body that judges everything according to 50s standards of idealization. But anyway, this is also a kind of idiosyncratic theory. But I think it's really interesting that you mentioned specifically that you use this in a kind of top-down approach, so to say, that you directly work with the students to develop this perceptual and also discriminating capacities. So I would give now the word to Eve Edelstein, who wants to make a question, and then to Milton Schinberg.
Hello all, lovely to see you. Question about aptitude of discriminating proportion. In your non-architectural subjects that you're currently testing, do you also assess their aptitude, even though it might be naive to architectural training, in the first instance, to understand where this range of subjects falls? Because it's very interesting which of the lay public are interested in, have an aptitude for these experiences. And then I have a second follow-up question on that.
Sergei, maybe you want to answer that?
Yeah, certainly. We don't do that yet, Eve, but this is a wonderful question. In principle, one could use this approach in order to sort of rank people in terms of their proportional capability. So just like there are people with perfect pitch, which, by the way, degrades with age. Those of you who have perfect pitch, the recent news are that you will lose it as you age. The same capacity could exist in judgment of sizes and proportions. So in principle, to answer your question, Eve, we could create this, I would call it a sort of system of scaling in which every individual could be placed, just like we have different visual acuities, different, I don't know, eye colors. As a part of your architectural personality, you could learn about your capability in architectural discrimination.
Mm-hmm. Excellent, thank you. I look forward to seeing that. I can imagine that will feed into my next question, is when you have very large sample sizes, then it'll be interesting to sort your subject pool. And my next question is whether or not this online test that you mentioned is open to anyone, or whether or not you have a selection process.
For the digital experiment we started, it was really an experimentation and happened honestly because we were under COVID and we wanted to have subjects coming, and the idea was to have students coming and give them possibility to both come to the lab and run the experiment with our machines, or be digital. And this gave us the opportunity to also test different points of view and different perspective for the experiment. At the beginning of the experiment, we have a consent form where we also ask different type of questions and details, and those questions are helping us to frame and understand the nature of the subject that is taking the test. That helps us to, at the end, when we analyze the data, to understand how to analyze the data, I would say.
So I suppose my next question is, now that I know that you're not currently seeking people trained in architecture, would you like us to forward the link to contacts that are not trained in architecture?
Yeah, what do you think, Sergei?
How big of a sample size would you like?
Well, in principle, I think this is a great idea to study these issues using this, crowdsourcing big data approach, using systems like Qualtrics. I don't know if you know about it in Europe. It's very popular in the States for all sorts of online experiments. So you could design any psychological or psychophysical or cognitive sciencey experiment and put it online for large numbers of people to take part. And you pay a relatively small amount to each subject, something on the scale of $50 per experiment. And you could produce very large data sets this way. The caveat of this approach, of course, is that you have no the sort of control over conditions of viewing that you have in the laboratory. You could ask people to exercise certain some caution in terms of distance and where they look at the screen, and you could certainly do that. Now, to answer your specific question about whether to forward this link to groups of students, I think our goal at this point is to calibrate these experiments in terms of discovering the conditions in which, in the two-dimensional mode of viewing, we get interesting results. So we want to find our stimuli, to find which stimulus conditions produce interesting sort of ranges of discrimination. In other words, we want to find where the differences in proportions presented in two-dimensional format fall in the part of human sensitivity where there's some action, really. So we are calibrating this, and I imagine in the very near future, within the next few months, we will arrive at that point. And if we keep this connection, so we will be happy, of course, to disseminate this link and ask everyone involved to try the experiment on themselves, and also subject your friends and students to this kind of experimentation.
Right. Yeah. Very good. May I make just one other point that has come up in previous conversations with the corporeal lectures? Very often discussion moves to architectural determinism. And then we move, in other words, can a piece of architecture actually make you move in a certain way or behave in a certain way? And the counterpoint almost is that a lot of what you've been talking about are subconscious, just noticeable differences. And so sometimes, although we might fight against a concept of determinism, our unconscious, subconscious perceptions are not necessarily known to us. And if we don't notice a difference, then we may not be determined how we'd respond. So Sergei and Tiziana, just love your feedback to that ongoing discussion.
Thank you, Eve.
Yeah, Tiziana, if I may, this is exactly the psychophysical question, and I'm just perfectly positioned to answer this question, Eve, because I've been thinking about this kind of issues for as long as the last 25 years. So to keep it short, first of all, I just want to clarify that the notion of perceptual threshold or psychophysical threshold is exactly the boundary between what Eve just called conscious and subconscious. And if you wish, if some of you have been at any point in your lives inspired by psychoanalysis, which is all about subconscious forces or unconscious forces driving your life, your experience, I just want to remind you that psychoanalysis is not really a scientific discipline. It was inspired by certain ideas in neurology, but in itself, it's not a scientific discipline. in the term, I mean, in the sense of what we mean by empirical science today, right? So what you find in psychophysics is really an attempt to answer the sort of questions that psychoanalysts were trying to answer in the early 20th century, but submitted to rigorous scientific testing. So what Tiziana and I do in I would describe it as an architectural psychoanalysis, if you wish, addressed to the question of proportion. And just one more nuance I want to add to this. So in experience of anything at all near threshold, you can just discriminate between three regimes. One regime is where you stand well above the threshold, and this is the domain of conscious experience. The other regime, deep down there under the sea level, is when you have no awareness and there is no chance for what happens to rise above the level of the threshold. So there is a regime of perfect consciousness and the regime of perfect absence of consciousness. I'm saying absence of consciousness because I want to avoid this psychoanalytical nuance between pre-conscious, unconscious, etc. But in between, there is that regime where things move in and out of consciousness, and this is the field that is most interesting here for designer, where you want to have effects subtle but effective. So if you knew about this range of physical values, so for example, proportion, the distance or size that operate in that realm, transitional realm between conscious and subconsciousness, you could find yourself in a very interesting position to effectively control behavior of dwellers, users of your design in ways that are really interesting. So the person, the experience inside, the user would not be aware of what's going on, but they would be sort of subconsciously, quote unquote, driven to do certain things in the built environment, move in particular direction, to get closer or farther away from some textures, etc.
But this is also where I will give the word next to Milton and then to Louise. But here I also have to make my own intervention, because I work with performance art. I am also, besides being an architect, I'm also a performance artist. And for a performance artist to hear this kind of design approach that has this deterministic component, and for example, the example that Tiziana gave before about the church and the liturgy, which is expressed through the design, this is exactly the juice that a performance artist works with, because we love to break these protocols. So it is, of course, possible, and scientifically, we really understand that you can design environments that somehow make people do certain things or act in a certain way, but you can always somehow reverse engineer this process if you have a cultural, artistic, or just idiosyncratic disposition to do it. You can decide, but perhaps you need there, and perhaps Sergei can elaborate on this. If a user has this awareness, there probably was a process of relationship with this environment that triggered also a desire for a certain kind of disobedience, or a certain kind of that the individual might be triggered to somehow decide to act against this protocol, or to reverse this protocol. And we saw it, for example, with certain, of course, religious buildings can be one example, but also every totalitarian architecture, for example, we know that they had very specific programs, but then in the long term, these things didn't really work, because they represented a political agenda, and they were used as also instruments of oppression. So perhaps you could elaborate a little bit on this.
Well, Sana, if I may take this question, the effects we're talking about, effects on perception, the just noticeable differences and potential effects in terms of inducing people into doing certain things. those are only possibilities. I would not call them deterministic in the sense that everybody entering particular zone or part of the built environment will turn into sort of somnambula and follow particular route. You know, these are all possibilities. So every kind of sensory mapping that we could talk about from the point of psychophysics has to do with what is perceptually possible. And one idea that I would like to introduce in this context is, for lack of a better term, I would call it outer unconscious, so to speak. So the possibilities of perception are there. When you enter the built environment, all these possibilities are present, and they form these maps, continuous maps from location to location. Now, whether or not the person will fall under the spell of this particular prescription designed by the architect is, I don't think it could ever be thought of as deterministic. Yeah, these are the possibilities. And the more sensitive souls, so to speak, whether or not they're trained in architecture, would feel that if they pay attention and follow the sort of the design, but others will not. So I don't think at any rate we could talk about determinism here.
I agree.
May I add that this range of responsiveness and I very much like your presence or absence of consciousness, I think that's a very apt way to think about it, is that there are different sensitivities, and if the architect understands the range of sensitivities, they can play with it more than if they don't have that information. And further, that experience will modify that, education will modify that. We do know from our balance and visual movement organs that it's a very plastic system. It is trainable. And so I'm excited to see the results of these studies from architects, artists, dancers, because they move through space, and so-called a lay public with lesser sensitivity.
Yeah, I absolutely agree with you. It's important for the architect to recognize that the person entering the built environment comes in different formats, so to speak. So Eduardo Macagno, a member of ANFA, who will speak here, I think in a week, right? Or in 2 weeks?
2 weeks, yes.
He likes to emphasize, for example, the variety of aptitude connected to age. You know, you want to imagine how the child and the adult and the person with decaying sensory powers would experience the same environment. And of course, in the same vein, you want to consider people of different heights, you know, of different experiences. Even as Yves just mentioned, you get educated as you move through the same built environment quickly. So you learn about you learn the sort of the language of the narrative of this built environment quickly. So depending on what direction you use in order to enter the built environment, you would have a different experience. So all of these factors certainly should take into account. And in perceptual sciences, we call it perceptual adaptation, which happens on the scale of several seconds.
And before I give the word to Milton, I would just add here a comment that what I find that is very valuable about this approach is that we can think about it in ways how very often we complain about the built environment, a square, for example, where nobody goes, the space is always empty and so on. And we can use this kind of information to tweak already existing buildings or already existing public spaces, for example, and insert perhaps some elements that use this kind of perceptual approach to be able to increase usage of people, or if we have areas which are perhaps prone to have actions of violence, of vandalism. Perhaps we can use them to create a different atmosphere. So this can definitely, I think the biggest potential that can be used with these tools, so to say, or methods, is really to understand how this can be used to have a positive effect in problematic areas.
Yeah.
Scientific equivalent of Ivy.
I would give the word now to Milton, because he's been waiting for a long time.
We cannot hear you.
We cannot hear you.
So Maria, first of all, I just wanted to say that I think one of the core values in art is tension. So it's not what you expect, it's what fights with what you expect, and that's artistic tension. Tiziana and Sergei, I really appreciate what you're doing and the way you're presenting it. It's fascinating for me. I'm an architect and an architectural educator who teaches neuroscience and architecture as one of my duties. And that, of course, gets to aesthetics and beauty. So I wanted to ask you a couple of things. The first is kind of a preamble, whether we share the same preamble. And in this case, I think it is intuition, but really suspicion or even bias against numerical systems of perception that don't have a demonstrable biological basis. So if I look at the golden section applied to the Parthenon or Renaissance, Alberti or whoever has come up with golden section and other kinds of proportions, I question what the basis for them is and the precision of those numbers. So as one example, in World War II, there were studies of the aspect ratio of periscopes, and the preferences came out to being not exactly the golden section, but a range. The golden section seemed to be roughly in the center of the preferences. So what makes me wonder is whether the subject is exclusively what we look at, but instead what we look with. So what fits the binocular cone of vision seems to fit nicely into the golden section. And artistic tension might be then things that violate or fight against that being a restful way of looking at the world.
I think it is very interesting question, especially like trying to frame better the intentions of our research in terms of re-understanding proportion. As you said, the proportion has a long history, and especially in the 20th century, golden section became really a burning issue. Many architects tried to apply golden section, and all of a sudden golden section became the proportion, like the one to be used. And we all know that this also was pushed thanks to Le Corbusier, who at that time, especially in the 1951 with the Milan conference, that was titled the Divina Proporzione, he promoted the modular. And many architects after him tried to apply the golden section. And the main thing is that even though at that time Le Corbusier was trying to justify the golden section as something that was connected to the human body, as we all know, he tried to understand how the golden section could represent different postures of the human body in the space. Still, it was presenting a proportion that was very ideal, made of different canons that came from a specific standard, the specific man with the specific height, with the arm raised. And of course, that series of proportion is still very idealistic and cannot relate fully with the human needs in terms of cognitive, physical, or sensorial needs. So the intention of the research is really to go back to the very understanding of what is proportion and why we need proportion, and re-understand the proportion without attaching it to any specific series of number or to any specific type of promised beauty that comes with proportion. And in terms of golden section, there are many interesting studies that demonstrate that there are many different proportional systems that Navon called the golden section sisters that are completely neglected, like the silver number and even the plastic number by van der Laan. And basically what happens is that the golden section, just like all these other systems, the only good quality is that they have high additive properties. And these high additive properties allow to better integrate those numbers into the building, because you have more variations and more possibilities. So what we really need to understand is what kind of proportions relate to the human perception. And then with that, we can understand at which degree we can take advantage of those additive properties to design the buildings that relate with the perception. So I think the main trouble, and with Sergei, we are now writing also another article that is called Proportion, Architectural Proportion Beyond Beauty, is first of all, we need to understand how we can, in a way, let's say, clean a bit the ground from the proportion studies in terms of aesthetics, because the idea about beauty really kind of pollute the ground. You cannot really be objective. You cannot really get to the core of what is the utility of proportion. And of course, beauty may come. This is a slippery concept when you talk about beauty in proportion in architecture. It may come, but it's not in the main intention. The main idea is to understand how the human being relates to proportion and how his behavior is informed by those proportions. I don't know if I answered your question, but it's a long history, the one of proportion, and I have been thinking about proportion for so long time. Before my PhD thesis, I was studying the proportional system by Leon Battista Alberti and the concept of consignitas. And after that, I came across van der Laan, and all of a sudden, I kind of re-understood completely proportion, because with van der Laan, I really kind of look at proportion from another perspective. I understood that it was not really about all those things that we architects talk about, beauty, symbols, all those kind of things. They don't tell anything about the building. They tell something about the culture and the society of the time. And this is what happened in the 20th century, when architects were confused, basically, because they couldn't relate anymore proportion to the building, because there was too much attached to the specific period of time. And now we can basically bring back proportion to the architects in a way that is valuable for all period of times and for all cultures. That is the goal of the research, I think.
You know, it's interesting because Chatterjee and Ramachandran are trying to really get their arms around beauty, and I think it is a very tough thing to do, except that one of the most powerful bodily experiences is that of beauty. So it should be measurable in some way, maybe not to say why it's beautiful, although I think there could be correspondences established, but the apprehension of beauty is very physical. It
is very physical, but maybe rather than and maybe Sergei can answer better on this, but maybe rather than measuring the reaction to beauty, maybe we can measure the effects. So we can measure what happens and how you act in response to specific, to specific conditions in the environment. And what you can measure is really that reaction. And for example, if I maybe try, and then Sergei can expand on this, but like if we find, for example, that such use of proportion may facilitate wayfinding in the building and facilitate the experience that you have in the building, and be able to move in the building in a more like confident manner and without indecision, that is still a pleasant experience. So we can say something about what happens in the people when they move in the building, and that may connect back us to the beauty. But I think that just trying to understand if one proportion is more beautiful than another, just like Fechner tried to do with the golden section and other architects try to do, is not valuable, because we cannot, and how we can take advantage of saying that one proportion is more beautiful than another when we are demonstrating in these experiments that maybe that proportion is not accessible to your perception at any rate. So you have the golden section imposed on a two-dimensional on a facade, and then it's supposed to be beautiful, but then you are in front of that building and somehow the golden section appears to be another proportion to your eye because of the perspective distortion. So at any rate, why you are assigning the beauty at that in the first place. So what we can really measure is, first of all, what are the conditions that better present proportion to our eyes, and how this can inform the behavior. And then we can analyze that behavior and then maybe understand at the very end the concept of beauty better. So this is my thinking about it. Sergei, you may want to add something on that.
Yeah, I mean, you put it beautifully, Tiziana. Just to frame what you're saying from the research perspective, I want to make this distinction of two categories of research in this domain. One has to do with perceptibility, and the other one with preferences. And Milton, as you put it yourself, preference of one aspect ratio versus another, it's a fantastic area for investigation. It happens to be not the one that Tiziana and I are addressing at the moment, but they're all, of course, all these questions, perceptibility and preferences, they are perfectly tractable using the sort of methods we are using, methods of sensory psychophysics. That's the first distinction I want to make. And the second one is about framing itself. So as you pointed out, people prefer certain aspect ratios of viewing devices. To generalize a little bit, framing is an important aspect of architectural design. Here at the Salk Institute, you cannot tell from my background, but I'm here at the Salk Institute, and those of you who have been to the Salk Institute know how framing of the environment is very prominent in your experience of the Salk Institute. As you walk on the sides or in these colonnades, the plaza and the entire sort of edifice of the Salk Institute is very dynamic because of the variable framing. And this is a question that could be used exactly the same methods that Tiziana and I are employing today. We have not asking this question yet, but it's perfectly convenient from that perspective to ask the question of whether people can discriminate certain aspect ratios in framing, in the sort of in the portals through which you see the environment. And certainly the question becomes whether or not your perceptibility of properties of framing are different from your perceptibility of properties of objects you're looking at.
Mm. Yeah, that's very helpful. Very helpful, and also exciting that there are prospects for looking at preference that would lead to some conclusions. Thank you.
Thank you so much.
And I think, if I may, your question about fighting against, or the comments about fighting against the norm, by understanding the range of responses of just noticeable difference, peak perceptual ability. So with just noticeable, then you go to what is, again, on this psychophysics curve of sensitivity, the most likely change to be noticed. And then you move beyond that. Once you understand more fully that range of any aspect, then you understand how to play with it. So let's push people outside of this, or push people towards peak perception, or push them towards just noticeable difference. And you know where the limits are more clearly than we do now, because you know what becomes discordant also if you push to the other end of the scale.
Mm-hmm.
We had a question hanging from Luis Villegas, and then I would like to give the word to the students, because I see that they have many, I see a lot of question marks in their heads, and we have one assignment from Mario, who would love to have a kind of improv workshop with you, because he's actually doing a project that would benefit a lot from your input, specifically with the experiments you're doing. So, Luis, would you like to comment? Yeah?
No, it was just a comment. Actually, a lot of my questions were, totally blown away with with what you just asked, and that magnificent description of what Tiziana was saying about proportion and how it influenced, how we have the new influence by something that was more aesthetic rather than understanding the real proportion of it from the last century. Just one of the few things that came to my mind when you were talking about all this, it was about when we, or the way you wanted to get information from people that were not architects, and which for me, that's a wonderful thing to put, because at the end, we have been so misled by what we had in our past or education about proportion or beauty, or what it means for us as architects. And I think around the world, rather than showing the reality of it and being really humans and understanding what it means to have the proportion in front of you, and what proportion mean, by the way. So that was it. It was just this comment, and thank you very much for Sergei and Tiziana for this wonderful talk and showing us your work. And I just leave the mic to the students. I don't want to take more time. Thank you very much, Maria. Bye-bye.
Thank you, Luis. So Mario, perhaps you would like to share your design project with us, and now we have this.
Yeah, sure, why not?
Yes, maybe you can briefly explain your idea and then share your screen.
Yeah. So first of all, thank you so much for your talk. It was very interesting, and as Maria mentioned, we've got a assigned task where we are to kind of like play with the idea of a shelter. So as for my part, I actually started working on something which, when I read up on your studies, was very similar to what you're doing right now. I'm just trying to pull it up right now.
Fantastic.
Maybe while we do it, I just give a little bit more information. So the task is to build a shelter, but the shelter is a conceptual piece. So it can be a costume, it can be an installation in the room, it can be appropriation of an area in a city or in a forest that has some land art qualities. So the interpretation is quite free.
Mm-hmm. Interesting.
All right, got it. Okay, I'm gonna share my screen. So I actually worked on a little mock-up of my idea. So the basic idea for me was how we perceive things. So if we're stuck in or put into an environment, how we actually see things and how we perceive them. So I was thinking about the shelter as an actual place. So we're using materials that just lay around our home or we can find very easily. So I was thinking about using paper for that.
Mm-hmm.
And with my idea, I'm now at the point where I'm not quite sure if I'm ought to like build a shelter, which, as you can see in this picture right here, follows like a systematic pattern, which in this case would be kind of like the spiral going inwards. And for a person to be standing inside of that shelter, I thought it would be very interesting to kind of like think about what that actually means if you're standing inside this thing. And and also what kind or how different sizes of those paper rolls actually make you feel certain things or move you to do certain things. And then on the other side, I thought about this concept where it's just kind of like a mess. There's no real pattern to it, so it just seems like everything is put in just as I go. And so these are my two options right now that I was thinking about. And like I said, reading up on your studies and on the experiment you were doing, that kind of like seems to fit in just about right to that.
Yeah, I think it does fit. And looking at your objects and the kind of articulation of elements you are attempting, I even think that some of these objects could test in our machines, like the perception of, because basically what you are doing, you are trying to investigate different sizes at different scale, right?
Yeah.
And expanding them and contracting them. So what I see here, if I may give a suggestion, just from like
yes,
point of view, like of an architect also, maybe what you want to do is to understand, the different contraction expansion you have of these objects, and also take into consideration the proximity between objects, the void, right? Because it seems that you are focusing a lot on the elements. And I think when we are studying also with Sergei the proportion, we are trying to understand the proportion of those solid elements. But finally, at the final stage, it's also important to understand the proportion resulting from the voids. So the space between the elements. Again, if you think about a colonnade and a series of pillars, it's not just important the proportion of the element itself, the pillar or the column, but also the proportion of the space in between, the gap, basically, right? The intercolumnio that we call. So I think it's very interesting. And maybe what you could try to understand is taking different perspective views inside this kind of assemblation of elements, and you could design different sequences of perspectives and see how these elements will start expanding and contracting and see what happens in terms of perception. So I think my suggestion will be double, if I can summarize. So one is to build a series of perspective views at the human height and see while you're walking how this proportion may change. And you could start playing also with the 3 points perspective and 2 points perspective and see what happens in terms of distortion. And then understand the proportion, not just of the physical objects, but also the spaces in between. Because that also is affects the, like I was thinking how much like the void, like the size of a pillar and the void that is in between welcomes you to pass the gate or not, or creates a resistance. You know what I mean, right? You are in front of a gate, and how much the proportion that is between the solid and the voids kind of helps you to move through, or just creates some kind of obstacle resistance, and maybe you don't want to do that because you feel that your body will not fit perfectly because the objects are too big and the space seems to be smaller. So all those kind of feelings that facilitate or not the passing through the gate, let's say, right? Or give a different experience. So I would say to evaluate the proportions of both three-dimensional objects and spaces and create sequences of perspective views to understand what is the experience.
Thank you so much for that.
Bye. I just tried.
And if I might add my sort of scientific angle to this.
Yeah, sure.
I just want to share 2 observations. One is that proportional systems could be used as a guide to help you in organizing the objects in space. So spirals, of course, are famously as geometric objects, they're guided by certain proportional properties, right? So you could use that in order to help you organize this environment. And as you do that, of course, it will help you on the one hand, but on the other hand, it will throw you into this doubtful sort of gray territory of asking yourself, what proportion should I use? Is this the right proportion? Is it perceptible at all? Things like that. So the entire first part of our conversation today will become suddenly very relevant. The second observation has to do with what is called perceptual organization, perceptual grouping. By the way, it just so happened that Hans van der Laan, about whom Tiziana was talking in the beginning, he did experiments on perceptual discriminability, but also on perceptual grouping. The question is, and I call it perceptual organization by its scientific name. It's a discipline of research in perceptual psychology, in cognitive science, and sensory psychophysics. The same questions are addressed from slightly different perspectives. So it has to do with which aspects of the environment, or which parts of the environment appear to belong together. And Tiziana mentioned proximity. Proximity, or spatial proximity to be precise, is one of the factors that determine which pieces of the world around you appear to belong together or not. And that will change in the distance, right? As you get closer in, of course, the same parts that appear to form a block or a unit in your perception from a distance, at a shorter distance, they would appear to separate and form objects of themselves. So you could read up on this. There's a huge literature. If you're interested, I could help you to find relevant literature. So the issue is perceptual grouping that I mentioned, and the other issue is called figure-ground segregation. This is a classical theme from Gestalt psychology from the early 20th century. Figure is what you experience. You perceive the world around yourself as consisting of certain objects. And the ground is what you don't experience. This is something that stands behind objects, that fills in, so to speak, behind objects. And the shape of that ground is usually not perceived. I think in architecture, you call it negative space or whatnot. This is something that is an aspect of the environment which you can pay attention if you like, and you could experience the shape of that sort of ground, the voids between objects. Yeah. So these factors are pretty well investigated in 2-dimensional format. So you could look at how distances and sizes affect perception of the organization of the environment. And then you could use this quantitatively to play with your proportional system. So your design could be constrained even more in this.
All right. Thank you so much.
And I must apologize. I have another call at 10:30. It's morning here in California. I will have to quit now, but this is the first time I joined this group. Thank you so much for having me. And
Thank you for being here, Sergei. And you are very welcome to join us in the next sessions. If you would have time, we would be very welcome to have you.
Thank you so much for the invitation, Maria. It's a very interesting forum, and I will try to take part as much as I can.
Thank you, Sergei. I don't know, Tiziana, if you have time to stay a little bit longer.
Yeah.
Is it okay? Thank you, Sergei. Bye-bye.
Thank you. Bye-bye.
So before I give the word to Eve, I would just like to add apropos something that Sergei just mentioned about this negative space. Mario, you probably remember that in these corporeal exercises that you had to do, some exercises work with a negative space and with a void. So maybe you can practice this again just to reactivate your sensitivity, and then also use this more physical corporeal experience to get a feeling for how you play with this space. So Eve, I think you have a recommendation.
Well, a quick question relative to space and distance, negative space and distance for Tiziana. When you did your experiment, are you controlling for distance between each object?
Yes, we do, because we build this grid on this shelf inside the machine, and also in the second experiment. And the grid is formatted with the one of the maximum length of the pieces of the morphodeck. And of course, once you place the objects into the grid, you control the distance in terms of proportion, because basically every time the proportion is incorporated in the grid, and you control in this way the distances between the objects. And we move the objects into on the grid. Since it's a 7x7 grid, you can have objects on the same line horizontally, or they can achieve some depth in the space. And then on the grid, each single location has a circle with different orientations, which are distanced of 15 degrees. And you can basically change the orientation of the angle of the objects. We keep one object standard, we call it, that is fixed, and the other one, which we call the comparison changes, and then we ask the subject to judge. So we perfectly control the distances, angulations of each object on the.
And thank you very much. And your distance is related to the dimension of the objects?
Exactly, to the system. Yeah, it comes from the morphodeck.
Greater distance with larger objects.
Exactly. It's basically coming from the 1-to-1 proportion, which is the square.
Okay.
Tiziana, I have a question for you that actually came in the beginning when you were doing a presentation. Could you tell us a little bit more about the history of the morphotic? How Van der Laan got to do it, because it's a three-dimensional game, so to say.
It is a game, and actually the morphodeck is just one of the proportional tools that Van der Laan designed. So I was lucky to live in the Netherlands for more than 2 years, and I went there because I discovered the theory of Van der Laan, and in Italy there was no way to understand what it was about. So I decided to move to the Netherlands. And I was lucky because I met one student of Van der Laan, Leo Tamberts. At that time I was 8 years old. And he asked me to move in his house and just train me, basically. And he had all the tools from Van der Laan that were the abacus, the 2 versions of the abacus, the morphodeck, and then the triangular forms. And basically, I realized that using those tools, that they were really games for architects, used to train the eye of the architect. And this is what Leo was trying to teach me. So we were playing together with these pieces, and the idea was every time to combine the pieces. There were different exercises there are different exercises you can do with the morphodeck. Some exercises are just purely to train your eye. So basically, since the objects of the morphodeck change scale, but they maintain the same proportion, you are asked basically to detect when is the same proportion at the different scales. So pick from the morphodeck the same proportions, even though the scales are different. And then there are ways also to have exercises to play with the void. So basically, since the morphodeck is all, of course, connected by proportional relationships, you can start building spaces with pieces where the void has its own proportion. Because with the pieces, you can control the distances and you can obtain blocks or slabs or bars into the space as void with specific proportion. And that one is also an exercise. So the morphodeck itself, van der Laan really realized the morphodeck to train architects, because he was teaching in a course, even though he's a Benedictine monk, his brother was an architect as well, and he was teaching. So he was teaching in this course that was the course for ecclesiastical architecture. At that time, there was need to rebuild the churches because of the war. And then he came into this course and he started training architects with the plastic number tools. And built all these tools. And Leo Tammers, this man, told me that the course was happening somehow somewhere in the Netherlands, far from his house. And one of the morphodeck, I mean, you didn't see it, but such tall and it's very, very heavy. And also the abacus comes with a luggage in wood with the handle to bring around. And he was every time bringing these tools to the school to train, basically, to be trained. And it's amazing. I mean, I think that my ability, my possibility to really understand the plastic number system happened because I was trained with the tools. Without the tools, it's very impossible, because it becomes very theoretical and you cannot grasp the intention of the system, which is very practical at the end and is for architects. So I think that I tried also in my teaching, I'm trying to incorporate tools to train architects, because I think it's a very valid system, especially for proportion. And the morphodeck is just a perfect tool. So that's why we are using it for the experiments, because it's a very perfect tool.
Thank you for this. It's also a nice story to imagine that you were personally interested and then you had this experience from learning with someone how to learn and play this game. And it's also really interesting to see how it's a tool that helps you to learn with proportion, and it's visual based, but it's also really haptic. These are solid blocks which are heavy, and so I have to remember about what we talked in the last conversation with Sarah Robinson about multisensorial experience and how the eye and the hand and the movement, how these things are coordinated.
And now that you say this, actually, what van der Laan also realized, one morphodeck in colors. So I just showed you the morphodeck, which is the one gray. But I realized the second version, which is not very, easy to find. But I was lucky to be trained by this student, so I had all the tools. And the morphodeck is built in colors. It's built with the colors that come from the blue to the red to the yellow from the top, and they meet down in the very center with the white forms, just like the spectrum of colors. And it's very sensorial object. So each single piece has a specific tone of colors. And when you put all together, you understand the place of each object in the morphodeck, because the blocks come all together and they become lighter when they get to the center, because they start losing the quality as a block and they start becoming something else. And the same happens with the bars and the slabs. So each piece is represented according to the change of proportion that is happening, transitioning from one group to another. And it's very sensorial, nice object, and it's easy to use. And again, you can do many different exercises. With this student, Leo Tammers, we started writing even a book to collect all different exercises that we could do with the morphodeck. But we never published it, and he was very old. I mean, he was more than 8 years old, and then he died, unluckily. But the idea was really to, because the morphodeck doesn't come with distractions, and you can really build so many different exercises when you start playing with it. So I think it's an interesting way also to approach education in architecture and also design in a way, starting from tools, physical, practical tools.
Absolutely. Well, this is a really fantastic and exciting input. I wonder if there are more questions. We have in the audience today some guests who were my students in another seminar, at least 3, which I always find very nice. Okay, I think at the moment everyone is a little bit quiet, so perhaps we can.
I've got another question. If I may.
Great.
Reading up on your article and what you just said about different colors, did it occur to you that like the perception of the different sizes in your experiment, if color is an indication for how good you perceive that?
Yeah, that's an important question. That's why we are now using just gray, painted gray blocks in our machines. And we also spend a lot of time to send, like we send the objects and then paint and send again. And we give like, I don't know how many covers to make that very smooth and nice so that there is no texture. And this helps to have the trustability of the judgment, because of course you don't want to create bias because of the texture. And also plus the color may affect the perception of the proportion, especially if you give like, for example, black piece or like a white or even any other color. So we are painting everything in gray and minimize as much as possible the texture when we realize the blocks. The true morphodeck as well, actually the one realized by Van der Laan was gray, like the one used in the exercises. So he built like basically actually 3 different morphodecks. One was the gray painted, then there was the one in colors, and there was one in stone. And the one in stone was amazing, very, very big. And I told you, I mean, I know all the people around Van der Laan, and basically he spent all the nights, like really in his shell, to just sand the stones to make them very, very smooth and nice, and they could match. And when I finished my PhD, I decided to build the morphodeck by myself. And only when I built the morphodeck by myself, I realized how hard it was to sand everything at the millimeter for the morphodeck to match. It took me really long time, because even if you send out like just less than 1 millimeter, the morphodeck will not match anymore, and you need to redo it because everything is just very precise. So it's really a good exercise to create the morphodeck, use it. It's really, I mean, interesting tool for architects in general. You can practice and exercise so many skills with such tool.
I think now we would all be really excited about playing with the morphodeck.
Yeah, absolutely. I could, like realize someone. Now I found a system to realize the morphodeck with the control numeric machine. So we have a machine that basically cuts the pieces. We built with Grasshopper a morphodeck generator, we call it. And you basically change one number and you can scale up and down all the pieces with the proportion. And then you can basically laser cut it, and you can even engrave the name of the pieces and the proportions. So I found like a more practical way, but I also did the by-hand system, which is very interesting for an architect. You learn so many skills doing the morphodeck. Well, if you're interested, I could train you or send you information to make your own morphodeck.
Yes, I think I would be interested in knowing how to do this, and I also know some people who would love to play with the morphodeck as well. I don't know if we have any more questions. Okay, maybe not. Okay, Tiziana, thank you so much for this wonderful and really valuable conversation. We learned so much today, and it was interesting and also exciting and wonderful to see you talking so passionately about your work and your experiments. It's also really inspiring.
Yeah, thank you so much. This is very precious for me. Every time I can share what I do is wonderful. And I thank you very much for welcoming me today here. Thank you so much.
Thank you. And I think, of course, our students and everyone in the audience who came to join us again, and for all their contributions. So until next time, bye-bye.
Yeah, bye-bye.
Bye-bye.
Bye.
Bye.